Hello students! Tashkent Institute of Irrigation and Agriculture Mechanization Engineer, Sozodo Fezos, and today we'll continue our lesson, and our lesson is development of real-time controller systems and how we can make them, principles of making real-time controller systems, and what is that, the real-time controller systems, where we can use them in technology process and watch the difference between the local control system and real-time control system. To understand this process, let's see a little example of this work, the principles of this work. As you see here, I have a little electrostatic set, and let's give the source. After the source, give a little effect. Let's kick the system. As you see, we have a light. And now we just turn off the source, and after a couple seconds, this system will over the work. Light, this red lamp, will be switched off. In all technology process, which we now have and use in controlling in intelligent systems, we use the programmatic logic controllers. As you see here, again a switch off. It means that we don't need a source in all the process of technology work. In this technology work, we need only simple step, only little impulse, only just little pushes to make a good controlling system, to make a real and, in some side, strong technology control systems. And in this, we need a special applications. And today, we will talk about this. After this lecture, I hope that you will understand what is that real-time systems and principles of making these real-time systems and create your own application on the basis of this real-time system, certainly in master SCADA program. And in this work, in this study, we first of all must understand what is the real-time constraint, what this system is meaning. In this graphic, you can see that eyes in the time period, this is an arrow in technology process, as you can now get it. Human control technology process in a real time continue this period. If we have any change in our technology process, we will understand. So here we have a little conclusion of that. Real-time concentration system is that must respond to events in an environment extremely time system. That's afford any changes and sense it and give any effect to this process. All the technology process is result of sensors. Sensors detect that your processes continue and have any changes. According to these changes, you must get this information and analyze and make a fast count process. In this fast count process, of course, do it by computer. But computer never understand what happened in your technology process, so you need a special application. And this application is special systems of real-time control. So today we'll talk about this. And now, why we use this real-time system? Why we don't need a local system? And why this better than other systems? First, this system works in serially time in period seconds. If you have any change in period seconds, it will be detected. Second, if you late or delay the process, some continuously it don't need. So we give the quality to our technology process. And the third one is that if you have an accident, you will detect it first and try to stop this process. In the same time, save your employers. So this, in point of this, real-time systems are better than local time systems or just a simple visual type of control. And let's talk about the principles of real-time systems, how it happens and what the basis of this technology system. Let's see the graphic. As you see, our graphic is in a cycle form and have 5 most important points of work this system. First of all, this measurement. To know what's happened, you need to see or hear. If you go in a far, let's imagine that your technology process in 1 billion kilometers far. And you must know what's happened. So you need a measurement, sensors. Second one is analyze. You must analyze what happened in your technology process and making counts based on this analyzing. Third one is making operation systems and make decide. All the decide which have a computer given your terms. In which terms you give the process, in which value you have action. And this all work in one thoroughly algorithm. This algorithm make decision. As you understand now, as you get it, last one is just making application support. Application support by your computer, connect the technology process, and in a single integrated system, make this control like a full body. You take two parts and make a single, and then it's continue to work. And the last one and most important is the accident effect. You must know that will or could happen the accident. This is all must be detected by your sensors. So we now understand the principles of work. So how we made the systems, how we make this automation control systems. In water economy, in agriculture, or just in technology process, we have a lot of process which happen. Let's just see here agriculture. Yeah, in agriculture processes. First of all, we have pump stations. It's water supplying. Second one is water purification. Third one is chemical process. Fourth is some mechanical work of transportation water. Five is harvesting process. And the sixth one is transportation process. As I count this, all the six processes have a different technology, acting machines, sensors, and rules and algorithms. All these algorithms is different, but they have one single rule. All the physical meanings are analogous signals. Can you remember that? In analogous signals, we can make digital signals. And these digital signals help to you use your computer. And this computer can help you analyze process as fast as it possible and show the visual. And your employers and engineers will know what happened in your object according to this changing of value or visual side. But you can say how we can make it. Let's talk about this. How we can make this our technology process and how will be continuous. First of all, we need to detect that we have a certain time of process of working and in which base we work, what to help you to work. Second one is understanding that when the action must change from first position to second, you must make a certain understanding how it happened. Third one, when it's come the outline. For example, you give one line of work and your technology process, value of technology process, come out this line. It means that you have an accident. But to know this all, you need to take a correct sensors. So how we can make this and what is that in basis? Let us see. Here we have an object. Here's a water purification state, a factory where the purification, the dirty water to pure water. And you see here all technology process, all the 6 technology process which I count before. You now to get it. All this technology process have a different physical values. So these different physical values needed correct sensors. These correct sensors must be taken by their technology values and technology characteristic. According to this characteristic, you will choose and select correct sensor. Here, you see a lot of sensors that are typical. There are more than 50 types of modules. Module, what is that, a module? Module is a special tool to take an analogous signal of sensor and convert it to need a value to your computer. If you choose an incorrect module, it will mean that measurement is incorrect and your technology process is dangerous. So first, which we need to understand, using correct sensors. What about the second one? Second one is explore the object. If you don't know what happened in object, just to make a principle of technology work. For example, water supply. Here, most important is pump. Here's rotation and pressure. Or in purification. Purification, first of all, we need to know the pure coefficient of the water. Not the pump, not our technology process, it's chemical process. So you need to choose the correct changes. Second was the structure. Create the correct structure. As you see here, we have a technology process the same, but your system understands it differently. So here we have a special 3 directions in a red arrow, in a green arrow, and a brown arrow. This is all the different technology process, and your computer understands according to this arrow lines, in red lines, in green lines, or in a brown line. All these lines has a special chemical or physical value, and this all value have their same sensor. According to the same sensors, you will understand how you can make this real-time controlling system. Okay, how we can see it in technology process, how it made. Let's see. Here we have one example is a pump unit. Pump unit have pipes with incoming water and outgoing water. We have here one difference between the pressure income pipe and outcome pipe. In the backside of this pump, we have a regulation unit. And then we have a pump. And before the income pump and outcome pump, we have a special sensors of pressure. And as you know, all the pump units use electrical energy. All the drive use electrical energy. So we must understand how much voltage we have and how long we can work. And is it safety to use this voltage? As you can see in the top side of this graphic, we have a voltage shield. And in the voltage shield, we have a special multiple system of measurement. And this system of measurement, call it again a sensor. All of them, as you can see, all these three sensors connected to the single one, which call it the computer. Computer will take this all basis, all this information of pump, and can match them all and make a calculation. And according to this calculation, you will understand, my pump will work fast or not enough. Pressure is low or pressure is high or pressure is critical. And you make your decision to stop process, to continue this process, or take a lower rotation of your pump. And according to your computer codes, you will take a lower, switch off, or switch on your pump unit as what you need. And the third one is a continue of this process, so principles. So in which we base. Now we'll get it and understand in the next slide. As I told you, connection to computer, make a special code, but how? As I say you, this all information match, but not match in computer, which called special OPC. And if you don't connect to OPC, it means that process is over. And let's see what will happen. Here we can see that technology process, which we have, computer, special service to connection to computer, and in the left side of this graphic you can see the screen of computer, what had happened. Now maybe you now get it that we have a special image or graphic of changing your process. Is it high, dangerous, normal, optimal, or low? This all information is just shown in your computer. You just push some buttons and actions will continue or change according to that impulse which you give in your logic controller. Logic controller will give the impulse of this set by computer to sensors, from sensors to the server, from a server to acting machine. And then you have an action. Like in a human mind, you in your mind make action that you need to work your hand, moving your hand, and then it's giving signal to your fingers and make a connection. Here we have a special connection. Computer is a mind, server is a line which is coming, and acting machine are your fingers. So it's the same. What's the processes we have? And but mind give the impulse, nervous impulse. What about the technology process? We need a program to control. Program make an equation between this process. Let's see one of them. Today we'll talk about the master SCADA. Master SCADA is a special operation system, as you can see here in our slide in the imagination. We have a special program which called the Master SCADA. This program has helped you to make a real controlling system according to your values, making physical values, make your rule controlling type. You have the ability to take your own acting machines and show in a schematic form, make a connection system, make a logical system, make a controlling system, make a remote system. All of them could be done in this application. And today I will teach you how to use this program and how you can make your own controlling system by now, step by step. First of all, what you need to know about Master SCADA is that it's have a level side of program. It have a special levels. First of all, you need to make your values. Let's take that we have a pump station again. In pump station we have three values, most important. Incoming water, outgoing water, and pressure. Yeah, three values. All of them have a direction. So as you see in this image, that all the codes of master SCADA have direction. All these directions, which I show you, show that indicators. All the directions are indicators. These indicators will link it to physical value, and this physical value will convert it to digital signal. And after this, will showing you in a visual form. But to know it, you need to understand the correct algorithm of work and structure. Let's see the structure. Structure from top to bottom come from a physical value, and down they go to tank, if you have a tank where you will harvest your water, and a lower it's going to regulator, which regulate in according to PID ruling controller. In the basis, all of them is controlling structure. Next, which we need is project development, making your project. When you make your values, physical values, you are making your algorithm of work, you make your sets. Last one is making this visualizing, as I told you. Here you have a good example of making this scheme. In the left side of this application, you see the one white type of circle. In this circle, we have some details: pump, tank, and level. As you can see here, this all values which you know transformed by you. You transform to this stream and take result. Here we have a special task, and this task is pump station. We have one pump, and this pump will give the water to one tank. In this tank, you will harvest the water and give to users. And first of all, which we need is make a correct functional stream. How it will be? Let's see. Here you see that in your right side you have the pump, this object which you need to make a controlling system. In the left side you have a stream or functional stream. You make this functional stream. In the downside of the stream you have algorithm of work. As you understand, as you get, we talk about the controlling water level. And in this graphic, in this count, you have H. H is a level of water, and it's equal to H controlling H. It means that you give a controlling command, and then value will change. But this command must take two values. First, G in. G in is the incoming water, and it's a plus to J out. J out, it means that outgoing water from a pump, out pump. So, as you get it, it's not easy, yeah, but let's continue what will be next. When you make algorithm, when you make a value, you need to make a counting process. And in application, we use a special command, counting. Here it looks like this. Counting, as you see, here we have a special indicators like red one, blue one, orange one, and green one. This is all have a physical values in the top side. Top side we have a special table. On this table you have a physical values. We will choose these physical values and then make our own equal, which we see here, algorithm of counting, which start from age. As you remember, we have a special algorithm of work. And this algorithm work will be used in the application to count side. Let's see how it will be looking. Here you have this counting process. Direction will be linked together. For example, here we have a income water, and it linked to the level in a red lines. Red lines, it means that they link it together. And this linking means that signal come and transform to the second one, and then analyze, and this result will be given to your computer. In this principle, it works. But how this counting is happen? Let's see about this. In the next slide, we see the counting process of this application. When we start the counting, when we understand that we have information, we need to make a history of changing. How it change in period of 1 day, for example. Is that work normal or no? You need to analyze it. As I told you, So we need to make database. If you have controlling system, if you have a program, if you have a system, you make a measurement, you have your decides, but you must know what will happen in period of 1 day. If you don't have information, why you need the system? So we need to make a database. And this application here, in the form of this application, show it how you can make information, how you can analyze, where and when change information. According to this, all the commands, you can make your own database and understanding this changing algorithm and ontology of changing. This, all of them is based on your database. Okay, cool. If you understand the database, if you understand the sensors, if you understand the value, if you understand the logic of counting, let's talk about the visualizing. And visualizing will start with making stream. Yeah, making stream. When you make your own set to use, you will transform it again, this stream to show, as shown in this image. Let's see the next step, how it will happen. In the next step, you will make database. In the downside, you see the graphic, yeah? You have a pump unit and a blue tank, and in the downside, you have a graphic of change. This one is a database. As you get it, this all value will show it in this visual form, and when this visual form is changed, change your process. In all the end, you just make your program and save it and can use it in your controller. This was the last information which I want to talk about you, tell you. It was very happy to see you again. I don't say the goodbye. Thank you for your attention.